So in this session, we're gonna discuss exceptions. So uh, a simple question about exceptions is, why do exceptions exist at all? So when you write code, you usually think about normal flow, like the happy path, but programs don't live in perfect worlds. Files go missing, inputs are invalid, network connections drop, uh, someone enters dog when we asked for a number. So exceptions are how Java says something went wrong and here's what it was. So they're not just random errors, they are structured signals that tell you exactly where something failed and let your program react. Maybe retry, maybe show a message, or maybe stop safely instead of crashing. So why exceptions exist? You can think of exceptions as two separate lanes in your program. One lane for normal execution, where things go right. One lane for error handling, where something unexpected happens. So the idea is to separate normal work from error recovery. That way your main logic stays clean, and your error logic stays focused. Another key reason exceptions exist is to fail fast with context. So if something breaks, Java doesn't just say oops. It throws a detailed object or object describing what, where, and why. You can catch that and print a message or pass it up the chain. And we have exception hierarchy. So now exceptions are all organized under one big family tree. At the top, you've got uh, throwable, and under that there are two main branches, which is error and exception. So error is things you don't handle. These are serious system issues like out of memory error. You don't catch these, you fix the cause. Exception are the things you can handle. This is what we deal with 99% of the time. So within the second branch, you have two kinds. We have checked and unchecked exceptions. So checked exceptions is the compiler forces you to handle them, like IO exception. Unchecked exceptions are also called runtime exceptions, like a null pointer exception or number format exception, which you can handle but you're not required to. So checked means this problem is expected and you should prepare for it. Unchecked means you probably messed something up in the logic, fix the bug. Um, so how exceptions work? Here's what actually happens when an exception is thrown. Some code fails and throws an exception object, and the runtime starts unwinding the call stack looking for matching catch block. If it finds one, your code handles it. If not, the program terminates and you see that familiar red stack trace. So think of it like a chain reaction. The error moves upward until something takes responsibility. So golden rules for exception handling is, there are few habits that separate clean professional code from messy, confusing error handling. First one, we have keep try blocks small. So only wrap the code that might fail, not the whole method. It helps you it helps you know exactly what caused the problem and catch only what you can handle. If you can't fix it or give useful feedback, don't catch it just to silence it. Let it bubble up to someone who can. And never shallow exceptions. So if you catch something, at least log it or rethrow it. Don't leave yourself guessing why your program just stopped working, and add context when rethrowing. For example, throw new IO exception. You open the new pad. So for example, throw IO exception error reading config file say plus file name. So that message will save you hours of debugging. So you are basically adding context when you rethrow. So exceptions are basically exceptions aren't about crashing. They're about communicating clearly when something goes wrong. So when you see a red error in your console, don't panic. Read it. It's literally the program telling you here's what broke and where. So once you understand the structure, uh, the this topic will start making a lot more sense. Uh, so so our first topic is handling exceptions. So now that we've talked about what exceptions are and why they exist, let's look at the most common question: how do we actually handle them? So handling exceptions is all about containing the damage, deciding what to do when something goes wrong, so your program can either recover or fail gracefully. Um, we have a try catch finally structure. So the main tool for this is the try block. So inside the try block you put the code that might fail. If something in there throws an exception, Java immediately jumps to the first matching catch block. So the pattern looks like this: try, catch, and then finally. So you can have multiple catch blocks. For example, one for file not found exception, another for more general IO exception. Order matters. Always go from most specific to most general, because once one matches, the rest are skipped. So imagine you're trying to convert user input to a number. So if the input is 123, it's great, no problem. If the input is dog, the Java throws a number format exception. So we put the parsing inside a try block, catch that exception, and show a friendly message like please enter a valid number. So the rest of the program keeps running, no crash, no red error dump. That's the point. So catch what you can handle, let the rest bubble up. And next we have checked versus unchecked exceptions. So you'll often see two categories: checked and unchecked exceptions. So checked exceptions, like things like IO exception, the compiler forces you to handle them. Unchecked exceptions are things like null pointer exception. You can handle them, but you're not required to. So the rule of thumb here is handle it if you can recover. For example, prompt again or retry or show a message. If you can't recover, just let it propagate and fail clearly. And so the finally block runs no matter what, whether the try succeeds, fails, or even throws an exception. It's meant for cleanup, like closing files or releasing connections. But there's a cleaner modern way to do that, which is try with the resources. So this syntax automatically closes anything that implements auto closable like readers or writers. You don't need to separate finally. The system handles it safely for you. Uh, and adding context to your exception. Sometimes you catch an exception but still need to throw it again. In that case, add more context so it's actually useful later. For example, uh, let's edit this. So yeah, this is an example for that. Now if someone sees the error in the logs, they know exactly which file failed, not just that something broke. Because we're printing the path. So common mistakes to avoid is catching exception too broadly. So this hides real problems and makes debugging impossible. And wrapping huge try blocks so they don't have, then you don't have no idea, you have no idea which line actually failed. Keep them small and focused, and doing too much inside finally. So remember, it should be for cleanup only, not mm, not more logic. So let's say you are reading a file called grades.txt. If it doesn't exist, catch the IO exception and show a message like file not found at the path. Then let the user know how to fix it instead of just crashing. That's clean, informative, professional, exactly what exception handling is for. uh, yeah, that's about handling exceptions. Next is we have now that we know how to handle exceptions, let's flip the perspective and talk about how to throw them yourself. So throwing exception is what you do when your method detects something it can't handle, like invalid input, a bad state, or a missing file, and it needs to tell the rest of the program, I can't continue until this is fixed. So the basics is throw new. So in Java, throwing an exception is literally just throw new some exception and message. So that one line stops a normal execution on normal execution right there, starts unwinding the call stack until someone catches it. You're basically saying, I can't finish this job, someone else needs to deal with it. So now there are two kinds of exceptions again, the checked and unchecked. The checked is basically the compiler forces the caller to handle them, like IO exception, exception. Unchecked is also called runtime exceptions, like null pointer exception, which can throw without declaring or forcing anyone to catch. When should you use uh, checked or unchecked? Use checked when caller can realistically recover, like a missing file or a bad connection. Use unchecked when it's programming error, like bad input, invalid state, or something that should never happen if your logic is right. uh, and then we have method contracts and preconditions. So a big part of writing reliable methods is documenting your exceptions, what's valid, what's not, and what happens if the rules are broken. That's what exceptions are for. If your method requires something specific, check it early, throw a clear exception. For example, if someone calls divide 10 comma 0, that's invalid input. So your method should check and throw uh, something like throw. Let me actually write it. Uh, so something like throw new uh, illegal exception divide cannot be zero. Yeah, this tells whoever call it exactly what went wrong without crashing the entire program. You can also use illegal state exception when something inside your class is is in a bad state. Maybe it's not initialized properly or used in a wrong order. So these are intentional signals. They make your code predictable and easier to debug. Uh, Now for checked exceptions, you declare them in your method signature with the throws keyword. For example, public void load config path p throws io exception. So that tells the caller this method might fail because of input and output IO, and it's your job to handle that. It doesn't mean the method always throws; it just can, and the compiler enforces that whoever calls it either catches it or declares it too. So that's the part of writing clean method contracts. Your method makes what errors might happen. Uh, and preserving the cause. So here's another important habit. When you catch and rethrow an exception, preserve the original cause. You do that by passing the original exception into new one, like this one. Throw new my exception could not load data ex. So this keeps the full stack trace, so you know what actually went wrong underneath. Without it, you lose context, and that makes debugging way harder. There are two big mistakes I see all the time, which is throwing unchecked exceptions for everything. So that's just lazy. It hides what actually recoverable, and losing the original cause. So rethrowing a brand new exception with no context wipes out the real problem. So always think, what kind of error is this? If the caller can fix it, make it checked. If it's their fault, make it unchecked. And if you rethrow, chain the cause. So that's a quick mindset when you're working with exceptions, throwing exceptions. So for example, imagine a method called load config path p. If the file doesn't exist or can't be read, it should throw a IO exception. The caller might catch that and say, could not open configuration file, please check the path and try again. That's friendly recoverable error. Now the contrast with divide a comma b. If b is 0, that's not recoverable. That's a logic mistake. You throw illegal argument exception with a message explaining why. So two different scenarios, two different exception types. That's the intentional design. So that's about throwing exceptions. Next one is exception with files. So now let's talk about one of the most common places exceptions show up, which is working with files. So when you read or write files in Java, things can and will go wrong. File might not exist, you might not have permission to read them, or the data might be in a wrong format. That's why it's not that's why it's so important to handle file related exceptions carefully, not just to prevent crashes, but to give users meaningful feedback. Uh, some common checked exceptions is when handling the files, Java makes you deal with checked exceptions. These are the ones the compiler won't let you ignore. The most common ones are IO exception, which is the catch all for input output problems. File not found exception, which is a specific case when the file you're trying to open just isn't there. Both of these are checked, meaning you must handle or declare them with a throws clause. These exceptions aren't bugs; they are just part of how file system works. So it's our job to make them clear and user friendly. The modern way is NIO.2. If you've been reading, if you've been using file reader or buffer reader before, that's fine. But the modern approach is to use the uh, NIO.2 API. I think I mentioned this in the previous session. So you can use files dot. Let me actually write it again. Files dot new buffered reader, path UTF-8. This is to read text files safely, or we also have files dot lines path. This is to stream lines. It's great for large files. And every time you open a file, use try with resources. It automatically closes your file even if something goes wrong, so you don't have to worry about leaks or forgotten close calls. Like for example, you can imagine reading grades.csv file line by line, doing something with each grade, and Java automatically handles cleanup when you're done. So that's an example for this. And then handling different error causes. So now, not all file errors are equal. You should distinguish between different causes. That's what separates a beginner program from professional one. So there are three big categories. First one is file not found. Maybe the file was deleted or user typed the wrong path. A message could be something like file not found and the path, absolute path, and the permission denied. Maybe the file exists but you don't have access. You could give a message like cannot read file and then your absolute path. And then we have malformed content. The file is there and readable, but the data inside doesn't make sense. Like example is a line like Alice comma ABC, where you expected a number. So instead of crashing, you can log the line number and skip it. So the key idea is here is recover where you can, report where you can't, and reporting full paths. So always report the absolute path in your error message using the path.to absolute path. It saves so much time when debugging, because grades.csv not found is useless if you don't know where it looked. So show the full path and you'll know immediately if the program is running in the wrong working directory. So some of the mistakes you'll want to avoid is assuming the working directory. So students, usually people often think the file is in their project folder, but depending on your IDE or runtime, it might not be. Always print the absolute path you're trying to read. And another thing is swallowing exceptions silently. Don't just catch an IO exception and pretend everything is fine. Returning default data silently makes debugging impossible. You want to know why the read failed. An example is, picture this: you're reading a grades.csv file with student names and GPAs. If the file doesn't exist, print file not found and the absolute path. If you don't have permission, print cannot read file and your absolute path. If you find a bad line like Ethan comma Apple, log bad data on line 3, Ethan comma Apple, and skip it. So that's professional uh, error handling. Your program doesn't crash and user get clear and specific feedback. So good file exception handling isn't just about avoiding crashes, it's about writing software that communicates clearly when something goes wrong. So that's all for this session. We're gonna discuss the rest of the topics in the next session.